Physics Part 184. Now it's your turn. Number 1. A violin string vibrates with a fundamental frequency of 440 Hz. What are the frequencies of its first two overtones? Number 2. The speed of waves on a certain stretched string is 48 meters per second. When the string is vibrated at the frequency of 64 Hz, stationary waves are set up. Find the separation of successive nodes in the stationary wave pattern. Number 3. You can make an empty lemonade bottle resonate by blowing across the top. What fundamental frequency of vibration would you expect for a bottle of 25 centimeters deep? The speed of sound in the air is 340 meters per second. Number 4. A certain organ pipe closed at one end can resonate at consecutive frequencies of 640 Hz, 896 Hz, and 1152 Hz. Deduce its fundamental speed. Deduce its fundamental frequency. So what you need to deduce here is the fundamental frequency. Well, next we've got the section summary here. A stationary wave is the result of interference between two progressive waves of equal frequencies. An amplitude traveling along the same lines with the same speed but in opposite direction. Points of zero amplitude on a stationary wave are called nodes. Points of maximum amplitudes are called antinodes. For stationary waves on a stretched string, frequency of Fn of the nth mode is given by Fn is equal to Cn over 2L, where C is the speed of progressive waves on the string and L is the length of the string. For stationary waves in the air, a tube closed at one end, frequency of Fn for the nth mode is given by Fn is equal to 2n minus 1c divided by 4L, where c is the speed of the sound in air and L is the length of the tube. We've got a few section questions. Number 1. State and explain 4 ways in which stationary waves differ from progressive waves. Number 2. A source of sound of frequency 200 Hz is placed in front of a flat wall. When a microphone is moved away from the source towards the wall, series of maxima and minima are detected. A. Explain what has happened to create these maxima and minima. B. The speed of sound in air is 340 meters per second. Calculate the distance between the successive minima. Number 3. A string is stretched between two fixed supports separated by 1.20 meter. Stationary waves are generated on the string. It is observed that two stationary wave frequencies are 180 Hz and 135 Hz. There is no resonant frequency between these two. Calculate A. The speed of progressive waves on the stretched string, and B. The lowest consonant, the lowest resonant frequency of the string. The lowest resonant frequency of the string, the speed of the progressive waves on the stretched string. Next we'll talk about the diffraction. It is in fact the separate section in this chapter when we talk about diffraction. And we'll give you all the details of diffraction in our next video.